So that's how elephants use infrasound. Now let's talk about the other and the acoustic spectrum of sound that is too high for humans to hear, ultrasound. Ultrasound is used by many animals that detect, and some of them send out a very high frequency sound. So, what is a good example? Yes, Kel? Well, bats, since they are all blind, bats have to use sound for, to keep them from flying into things. That's echolocation. Echolocation is pretty self-explanatory, using echoes, reflecting sound waves to locate things. As Carol said, bats use it for navigation and orientation. And what else, Mike? Well, finding food is always important, and I guess not becoming food for other animals. Right, both count avoiding other predators and locating prey, typically insects that fly around at night. Now, before I go on, let me just respond to something Carol was saying. This idea that bats are blind. Actually, there are some species of bats ones that don't use echolocation that do rely on their vision for navigation. But it is true for many bats. Their vision is too weak to count on. Okay, so quick summary how echolocation works. The body emits these ultrasonic pulses, a very high-pitched sound wave that we can't hear. And then they analyze the echoes. How the waves bounce back. Here, let me finish this diagram I started before this class. Well, the bat sends out the pulses very focused bouts of sound, and the echoes bounce back. I don't think I need to draw the echo. You're in the assignment for the next one. It has the diagram that shows this really clearly. And so that's what I'm saying. By analyzing this echo, the bat can determine, say, if there is a wall in a cave that needs to avoid. You know how far away it is. Another thing it uses the sound to detect is the size and the shape of object. For example, one echo that with the common prey for bat, particularly a moth beating its wings. However, moths happen to have a major advantage over most other insects. They can detect ultrasound. This means that when the bat approaches, the moth can detect the bat's presence. So it has time to escape to safety, or else they can just remain motionless. Since when they stop beating their wings, they will be much harder for the bat to distinguish from a real some other object. Now, we've tended to underestimate just how sophisticated the abilities of animals that use ultrasounds are. In fact, we kind of assume that they're filtering a lack out. The way a sophisticated radar system can ignore echo from the stationary object on the ground. Radar does this in move ground craft. Information about the health or buildings that they need. But bats, we thought they were filtering out because the simply couldn't analyze it. But it looks as if we're wrong. Recently, there was this experiment with trees and specific species of bats. A bat called the lesser spear-nosed bat. Now, a tree should be a huge acoustic challenge for bats, right? I mean, it got all kinds of surfaces with different shapes and angles. So, well, the echoes from a tree are going to be massive, chaotic acoustic reflections, right? Not like the echo from a mouse. So we thought for a long time that the bats stop the evaluation as simply that is a tree. Yet it turns out that the bats are at least a particular species. Cannot for only tell that it is a tree, but can also distinguish between, say, a pine tree and a deciduous tree. like a maple or an oak tree, just by their leaves. And when I was saying I mean pine needles too. Any ideas on how we to know that? Well, like with moss could be their shape. You're on the right track. It's actually the echo of all of the waves as a whole that matters. Now think a pine tree with all those little densely packed needles would produce a large number of fine reflections in what we call a smooth echo. The waveform were very even, but an oak, which has fewer but bigger waves with stronger reflection, produces a jagged, what we call it, a rough echo. This one, and comes in a small or rough shape.